my ultimate goal is to generate those reports for the end user which he wanted. For that, I'll have to create in the data warehouse in the where I'm storing all the data coming from multiple sources. I have to create that would be another again in the tables and columns, right? So I have to create such tables and columns which will fulfill the requirement, so that in from those tables I can directly that query those table and get my information, and those reports, whichever information in those reports the end user wanted, I can provide that. So to fulfill that requirement, we introduce some concepts. They introduce some concepts. That is among them is the kind of data a table will store. Like we have learned the concept of normalization, that it will be normalized and denormalized and everything. So continuing the same, I wanted such table so that the user can directly query them and can run the report, and that should be faster also. To fulfill that thing, to create such a model, to create such tables and columns among in the data warehouse, we introduce some concepts. That among them is fact table and dimension table, for the tables especially. So a fact table is which will keep the facts. It means the calculated information, the aggregate information, the measures. It will directly have the measures. I mean, and dimension table also. See, like sales amount or percentage or revenue, these kind of information which is already calculated. What normally we do, we have the data, we have the tables, we apply arithmetic operations and generate a column, and then we get that information, right? What if I already have that calculated value in my table? That would won't that be easier and nicer? So same way, when I already have calculated columns, calculated information in my tables, that is called the fact table. It will have the facts, so that those tables can directly be queried and you don't have to apply operations further in that, and you can get the right data into your reports. So that is called fact table. Now, how that data which is stored, like the sales amount, for example, sales amount column is there. Now the value on which you are applying the operation, okay, or applying the arithmetic operation or aggregating, from where that data is coming, that you will require some data, right? So that data is like employee information, customer information, sales figures, accounts information. Those will be different table altogether again. So for that they categorize, like, okay, if I have the calculated information is stored, that is a fact table, and if I don't have the calculated information, that would be a dimension table. It means, let's example, see, employee table is there. Okay, employee table will have employee name and such information, which is the information which is non-numeric in nature, the names, the details, the address details that I have. Now, I have salary. Now salary percentage, if I want, then salary percentage would be a new column, and I'll keep that column into fact table, not in the dimension table. So dimension table will have the category of information like time and dimension, customer dimension, account dimension, sales dimension. Dimension means non-numerical information that will have columns on which you can calculate and keep a new column into the fact table. The information which is coming in the fact table is coming from the dimension table. On the columns which are present in the dimension table, you are applying rules over there, you are applying arithmetic operation, you are calculating there, you are doing aggregates on that, and you are storing that information into fact table. So understand, the information is with me, I have the information, so that, and so I'm cutting the numeric part of that information from the and that I'm calling the dimension table, and keeping that calculated information into fact tables. I'm just segregating it so that it will be easier to access. Okay, so that is dimension table and fact table. Now we knew that to keep in such a structure, so that the reports can be generated directly, so that those are easier, faster, and fulfilling the requirement. So we went for fact table, where I have already aggregated information which has a measures, and I'll go for dimension table, which will have a category of information, will have non-numeric information like customer dimension, time dimension. Time dimension will have what, the hours, minutes, seconds, like this, dates, geographical information, time. So like that, I'll have those information. Based on that, I'll have one column from time dimension, one from customer dimension, and I'll calculate, and the output column will be stored in the fact table. That's how we go. Now now I have fact table, dimension table. I have to structure my data into data warehouse also in the way, so that I can query. For that, we have a concept which is called Star Schema and Snowflake Schema. I'll tell you what Star Schema is first. See, first, Star Schema means scheme. Okay, in what scheme your fact table and dimension table. Now we will talk in terms of fact table and dimension table only. We don't have normal tables in ETL. Those are top tables, but because of the features they are having, they are being called fact table and dimension table. And in the data warehouse, in that database, you will have fact table and dimension table. Okay, it's just a name you are giving because of these features. These are the tables only which you have been using, which are the same table in the Oracle. When it goes to a data warehouse, if you're keeping only the measures, then it will be a called fact table in data warehouse. So same thing, but with a few added feature. So you're calling it fact table and dimension table. Now these fact table and dimension table are organized in a way into data warehouse, so that they can generate your reports or data marts. So among them is Star Schema, the scheme in which they will be organized. Star Schema will make a star-like structure. Okay, so it would be one fact table and associated would be multiple dimension table. It means, see, now you will be more clear about how the facts will be calculated. One fact table, one measure information will be there. Okay, measures, aggregate information, and which are coming to calculate that fact measure column. The information is the values coming from one dimension table, or second one, or third one, or fourth one. So when there is one fact table associated with multiple dimension table, and you know how it will be associated, it will be foreign key primary key relationship, right, which we have already understood. So these would be that if you are keeping your dimension table and fact table in such a manner that there will be one fact table associated with multiple dimension table, that is called Star Schema. Okay, and one more concept, if you are adding one more level of dimension table. Okay, see here, we go for, I'll tell you the usage of denormalization, normalization. Now see, this dimension table will have all the information. It will have the redundant data, it will have all the details in that. Okay, so these dimension tables are denormalized. You don't have another level of information in it. It won't be like if customer information are in this one and customer's address would be in another one. No, address information also is in this one. This is the customer dimension, this is the time dimension, and the sales dimension. So I don't have a further level of dimension table. I'm not splitting it into one more table to organize it better. So that is called denormalization, and that is extensively used in ETL. So Star Schema is done, one fact table and associated multiple dimension table. Now Snowflake Schema is when you are having another level of dimension, that is normalized. Again, obviously this information is not complete in this table. Further information is there in this dimension table, and they are connected based on primary key, foreign key. So whenever you have such kind of relationship, you are organizing your dimension table and fact table in such a way that dimension table has another level of dimension table, that makes a Snowflake Schema. So there are one more galaxy, but these are the basic ones and most used. And to performance wise, now decide which one be faster. Of course Star Schema would be faster because there would be less number of joins in that, right? Now These are the way the data warehouse is built, the architecture. And see, now you get the bigger picture. Like, I want to have all my the simple requirement was to generate my report based on the thing, so that I can have all the information coming from multiple sources into one place. But keeping that information to one place has to be organized in such a way so that my reports, that the requirement can be fulfilled. So for that we went for fact tables, dimension table, and that fact table and dimension table also were organized in such a way. So there are two people, very important people in ETL, Bill Imon and Ralph Kimball. They have their own strategies and definition, so that how the data warehouse process should go, how the architecture would go. So Bill Imon said, just go for top down approach. Top down approach means, it's he's saying in the this data warehouse architecture, he's saying top down means you build the data warehouse first, and after that you split the data into data points. Because from the big pieces you can split the pieces whatever you want. So go for that, and keep the data into third normal form means put it in a Snowflake schema. I mean, first point, these are different points. First point, he said go for top down approach means first build a data warehouse, then build a data mart, like we can see here. Then we are building the data mart. Okay. And also he said keep the data into third normal form. It means keep it normalized, have another level of information, that is nothing but the Snowflake schema which we learned. So that's what he said. But Kimball said that go for bottom up approach. What is that? Bottom up, first build the data marts. Okay, first take the information from different department and then merge it into one data warehouse. That what he wanted to say. And keep it in the star schema and keep it denormalized. What these are the features and methodologies which developers follow while creating their data warehouse. It's just for a tester, for you it's just a good to know concept. You should know that, and maybe while going in interviews you can tell and impress them with your knowledge that you know that. So Bill Lemon said go for top-down approach, use 3NF and use Snowflake schema of course. And Kimball said go for bottom-up and it will be denormalized in star schema. So that will be faster one. So now understand why we were going. I was telling you the normalization and denormalization. Why we understand the architect and why we understood this star schema and Snowflake schema, because these are the methodologies which the developer, the architect of your project would be following, and they would be deciding and creating how many dimension table would have, what all dimension would you have, what all columns you have, how many fact table you will have, whether you will go for star schema or Snowflake schema, you want performance better or less, this slow would be okay with you, how many joins would be there, these all kind of things. Okay, and that all comes from these concepts. They also have to be clear on these concepts, what is that first. So now in the architect, I'll go through once. We extract the data from the source, it goes to staging area, we do the cleansing, scrubbing and everything in there, then we move to data warehouse, and then we apply the business validation to transform and everything, and then you create data marts out of it, and then you can create your reports. And in that, if you switch it other way around, first you create the data mart and then go to data warehouse, that would be building Kimball methodologies. So it can be in your project that you are using the other one, and then you'll in the ETL process you'll load your data mart first, and then you will load your data warehouse. So these are the concepts. Just go through it once. I know it can be a bit tough for you to understand first time. Go through the video once again. Any questions you can feel free to contact us anytime. And happy learning and keep learning.